Cool. All right, we're recording. All right, welcome everybody. Welcome to the Demo and Tools track for the AI for K12 showcase. I'm Joey Isaac. I'm an HCC PhD student at the University of Florida. I'll be your session chair for today. Please everyone mute your mic except for the current speaker at the time. Each speaker will have 12 minutes to present, and this 12 minutes includes a question and answer session. Speakers can moderate their own question and answer session, and I'll give warnings at the 5-minute mark remaining and the 1-minute mark remaining. So I'm going to introduce our first speaker, which is Alex Chen from Google. Alex, the floor is yours.
Hi, everybody. Nice to meet you all virtually, and I'm excited to share with you. So let me go ahead and start sharing my screen here. So here I'll hit present. So I'm Alex. I live up in Massachusetts. I work at Google on a team called Creative Lab, and I wanted to share a tool that various teachers and classrooms have started adopting called Teachable Machine that we created. And mostly today, I'm just going to kind of demo the tool, show some things that people have started doing with it, and happy to answer questions and steer the conversation in whatever way is helpful. So what Teachable Machine is a really fast, easy way for anybody to make a machine learning model in your browser. I'm going to show two versions, and I'll just go right into a little live demo here so I can kind of show you how this tool works. So to use Teachable Machine, you go to the website, Teachable Machine with Google, and what I'll also do is maybe I'll share around these links afterwards. Click Get Started. Clicking an image project is always the easiest way to start. So the demo that I like to show when I'm kind of introducing the concept of machine learning to people is that I can teach a machine to recognize something using my webcam. So I'll just name this first class me, and I'll just hold down record here. If everybody can see, okay, I'm just capturing some images, examples of me. And I'll name this second class me plus something. And I just grab any object that I've got sitting around. So I'll just take this water bottle and kind of hold it up. And so I'll capture a few examples of me holding a water bottle. And then I'll add one third class where I'll just say not here. And it could be anything you want. So on this one, I'll just duck out of the frame for a little bit, capture a few examples of that. And then I can go ahead and train a model right here in my browser. So it'll take a few seconds, depending on how many classes you're trying to train here. And one of the fun things about Teachable Machine is that you'll see when it's done training, you can actually try out your model right away in the browser and instantly kind of play with your model and see what it detects. So once it's done training, you'll see over here on the right, if you can all see this okay, hang on, let me just move the Zoom window, so down here you have confidence bars. So right now the machine learning model is returning 100% confidence that it's the me class, but as soon as I hold up the bottle, it returns the me plus something class. And then when I duck out of frame, it's the not here class. But one of the really fun things that you could start to play with the model right away is, at what point does it kind of start to get a little bit confused and it's a little in between classes, because right now the bottle's half in, so it's a little bit, it's kind of close to the me, but it's kind of close to the something. And one of the other interesting things that I like to show people is that it hasn't learned specifically what a water bottle is. It's actually, if I hold up any object, it'll probably just decide, hey, that's a little bit closer to the me plus something. I'll just grab a pair of scissors, anything. Although that one, it doesn't seem quite as, it seems a little bit more perplexed as to which class to choose. But I think the important concept that I really like to tell my friends when I'm teaching them about machine learning is that it hasn't learned what a water bottle is or what I am. It's really just matching patterns of pixels. So at all times it's saying, hey, based on what I know is what I'm seeing in the webcam closer to the examples you showed me in the first class, the second class, or the third class. And it's really just matching patterns of pixels. And I think that's a really, that was a really eye-opening moment for me when I was learning about machine learning, that it's just pattern matching. And I think that's sort of a really important thought to carry throughout. I did also want to demonstrate that there's a second older version of Teachable Machine, and this is actually where we started the project back in 2017, which is also still online, which might be more useful for certain classroom scenarios. And in this class, and I'll kind of just quickly do exactly the same exercise I did before, in this version, and I know I'm going pretty fast just to kind of show as much stuff as I can, and I'm happy to slow down and dive in deeper into any of these. So I'll train the last class again with just me. In this one can be fun depending on your scenario because we are immediately have the computer doing something on the right. So in this case, it'll actually play a different GIF on the right based on what class it is. So as soon as I hold something up, it'll trigger to the dog, and then the cat, and then the dog, and then the cat. You can also click on sound. So right now it'll play bird sound, and then when I hold something up, it plays a little electric guitar solo. So it's sort of instantly fun that you could just kind of, and then when I duck out, and then finally there's a speech class, which is sort of fun. You could write like "yay bottle," and then I'll write "where'd you go" in the last class, and then so
where'd you go? Hello. Where'd you go? Hello. Where'd you go? Hello.
And when I play with this demo with my kids who are still young and learning about technology, it's a really fun moment here too, where I think putting the learner in the seat of the creator, where that you can type any speech into that bit on the right. It's not that the computer's learned who I am or what a bottle is. It's really you as the creator of this system can really steer what you want it to recognize, what you want it to do when it recognizes things. And I think that is a really kind of fun moment to explore that I found. I'll quickly jump through some slides just to show you some examples. Also, I thought I'd get a quick time check. I haven't been keeping track. I'm about
5 minutes left.
Okay,
5 minutes left.
All right. So I'll show you some examples of things we could do. This is a fun demo where I was just showing that you could play like air guitar with your hands. Here was one where I like to train it on origami because I thought that's a really fun one where I'm holding up an origami bird and then I'm holding up like a ghost and making it play a Halloween sound there. Here's something, there's tons of things that teachers are doing with Teachable Machine that you can find on Twitter and are sharing in other ways. Here's an example of a teacher that was actually having a lesson about self-driving cars where they're training it on stop signs and cutting out pieces of paper and holding up the stop sign to the webcam. There's a really cool developer student club in Nigeria where they're training it on local dance moves that were important to them. And I thought that was really neat, of people bringing stuff that they love that matters to them to machine learning models. Here's another example where Girl Scouts were training it on different dance moves like flossing, dabbing. Here's some more examples. Here's one of the sort of dance model in practice. And I didn't have time to go into this, but Teachable Machine will actually let you train. I showed you the image mode. You can also train based on short sound samples, and you can also train based on your body movement. So the body has actually been a really great one for learning and for the classroom, because I think, students and kids using their bodies, we've seen teachers have found is a really just fun way to learn about machine learning models. And what's important here is for the kids to understand is that it's training on the pose points. So on your pose, not the pixels of the camera itself. And then, for more advanced students, like here's a college student that actually trained a class based on their hands, but then we're actually playing a game with it. And then finally, I can share these around in whatever way is best. People are starting to develop curriculum using Teachable Machines. So some friends at MIT Media Lab are using body pose, combining it with Scratch in different ways. Blakely Payne is a really amazing MIT researcher who was at MIT at the time and developed a great curriculum around ethics and machine learning. And then finally, there's some examples of combining with Arduino and physical computing, and there are tutorials online. Like, it's a pretty neat moment to be able to like snap your fingers and have something happen in the physical world. And another example we did, which I can share, is sorting is a really fun metaphor for machine learning, of having a little sorting machine. In this case, it was putting little pieces of cereal and marshmallows, and if it detects cereal, it'll dump it one way, and if it detects a marshmallow, it'll detect it another way, to try to have this little paper sorter dump into two different buckets. And then finally, I didn't have time to go into this, but some of what our team does at Google is try to create these experiments, many of which enable like hands-on ways of exploring and learning about machine learning and AI. So you can find more of those at this AI Experiments website. So I can stop there for questions. I know we have a few minutes left, hopefully, or maybe just a couple.
Yeah, 2 minutes remaining.
Quick question in the chat. Any issues about, kids' pictures showing up here and being stored as far as privacy concerns?
Yeah, so you can go to the FAQ. It's all, no image data is ever sent to a server. All of the image data always stays completely on your device, unless students choose to log into Google Drive and back up their entire project, at which case it's like a very clear flow that they'll do that. But by default, when you open up the website, all of the training is happening on your computer. So.
And do we have the link to this presentation? I didn't see it.
Not yet. I can maybe figure out who to coordinate to share it out.
A lot of good stuff in there. Thank you.
Thank you.
If you can't see the chat, you're also got a question about where can exported models be used?
Okay. Actually, let me just stop share because somehow I lost the chat. Exported. Okay. So yeah, so I didn't show this, but the new version of Teachable Machine will let you make a model and then actually upload that model to the web instantly, host it for free, and then you can actually, if kids know how to program with Glitch or P5, they can actually use that model in their computer program. So if a kid wants to do anything like the game that we showed where they're controlling a game, they can do that in whatever programming language can accept a web model. It's a pretty beginner-friendly coding exercise, and there's some really nice tutorials. One of our favorites is the Coding Train, has a great set of tutorials where he shows how to do it in p5.js. And again, on the privacy note there, it's a really subtle thing, but all of the training data never gets uploaded. It's only the model itself, which doesn't have any of the pictures of training in it, but just the model itself is what's being stored and hosted. Chat.
Cool. Thank you, Alex.
Okay.
Yeah.
Thank
so
you,
we're
Joey.
out of time, so we're
Okay.
Yeah, I appreciate it. But feel free to answer any additional questions in the chat that may still be lingering. We're going to go on to the next presenter, which is Dale Lane from IBM. So Dale Lane, you can take over the screen. Dale, you're on mute.
There we go. Now can you hear me?
Loud and clear. Thank you.
Perfect. Thank you very much. So yeah, I'd like to introduce Machine Learning for Kids, which is a resource I created to enable children to learn about machine learning. So my goal has been to enable learning about ML through first-hand hands-on experiences, through a training tool and like a sandbox that students can use to create an experiment with these technologies for themselves. So the site allows students to create their own custom ML models and then use them from platforms that they're already familiar with, like Scratch and App Inventor, and try to explain a bit about what's happening under the covers along the way. I also provide a library of pre-trained ML models that they can use to make all sorts of cool projects, and let them import models they can get from other places like TensorFlow Hub or Teachable Machine that we just saw. So I'll start with the training tool. So it's a simplified UI for collecting training examples for supervised learning. So they see the classes they define as these big simple boxes, and they see the training examples that they're collecting in those boxes. And they can use this to create models for different, with different types of data. So what I'm showing you here is for training text classifiers. But even here, you can train a variety of types of text classifiers. So you can do simple intent classification, or things like sentiment recognition, but the interface for students is the same. Students can train sound classifiers by recording short sound recordings with their microphone, and they can use this to do things like simple speech recognition for a small number of words, or to recognize types of sounds like different musical instruments. They can train image classifiers, and they can use training images they find on the web that they sort of drag into their training bucket, or they can draw their training images on an on-screen canvas, or they can use their webcam to take a training image that way. And they can train simple decision tree classifiers using structured data. So, you know, with like numerical data and categorical training data. But for all of these, you know, text, images, numbers, sounds, the concepts are presented in a consistent way. Essentially, it's supervised learning by creating buckets that hold training examples that the students collect for themselves. And once they've trained a model, they can use it from coding environments that they're often already familiar with, like Scratch. So blocks that represent the machine learning model they've trained are automatically added into the Scratch toolbox for them and pre-configured so they're all ready for use. And as you can see here, the blocks can be used for classification, but more than that, there are blocks for collecting additional training data and for retraining their model with the additional training examples. They can also create projects from Python. So the site generates sample starter code and displays it in the browser for them to download and run locally, or they can code directly in the browser through integration with REPL.it. They can create ML-powered mobile apps using App Inventor, and it's similar to Scratch. So blocks for their ML model are automatically added into the App Inventor palette. And there are blocks for classifying using their models and for doing things like adding training examples and so on. Students can try out their custom model from the training tool, and this will display the top result for their test values together with the confidence score for it. So they can start experimenting with their model before they start their project coding. To help them understand what's happening under the covers, decision tree classifiers that are the ones created for numbers projects, they're visualized in the training tool. And what they get is an interactive visualization that lets them see the decision tree that was generated from their training. And it shows them how their decision tree is used to classify different test values that they input. So as you can see here, as they put in a test value, the right nodes of the tree get highlighted so they can see how the examples that they've put in are used to classify and to recognize the numerical data. To help them understand the neural networks they train for text models, an interactive visualization walks them through the kind of principles involved. And this is a visualization that is customized using the training examples that they've done in their project. I also provide a small library of pre-trained ML models that are available for use in Scratch. So this allows students to experiment and to play with models that would need too much training data for them to reasonably do it for themselves. So for example, you know, some of these can be done, can be used for some quite complex projects, like being able to recognize toxicity in text found on the internet. But others can be used to make just really fun and simple projects, like using a face detection model to move Scratch sprites to face landmarks. Imagenet is another pre-trained model that can recognize more classes than a student could reasonably train by themselves. But TensorFlow models hosted externally can be used in Scratch. So this can be from sites like TensorFlow Hub, where there's loads of models that are freely available. But alternatively, what I've done before is create a custom model in Python ahead of a lesson and then convert it to TensorFlow.js using TensorFlow.js Converter, and then make it available for students to use. So if you know what you're doing, there's like pretty much any model you can bring into Scratch. But a much simpler way of doing it is to import pre-trained models from Teachable Machine. And I won't go through how this works because Alec has just shown us that, but it's awesome. But what we can do, and he sort of touched on this in the Q&A, that once you've trained it, they host it for you for free. So what you get is a URL for your particular model, and then you can take that and then bring it to the Machine Learning for Kids site. And then from there, you can open the model you've just trained in Scratch. So you sort of click on that and then you paste in that URL from Teachable Machine, and then students can make their own projects for it in Scratch. And the blocks show up in the same way for the models that they train in the Machine Learning for Kids site itself. So it's all sort of looks exactly the same wherever they train the model. So the source code for the training tool that I've been showing you is available on GitHub under an Apache license. And the most obvious impact this has had is that really generous people around the world have contributed translations. So the site can be used in 19 different languages. I've also written dozens of project worksheets, and these are sort of step-by-step recipes for how to make ML-powered examples of a range of real-world AI applications. And these are there not to be prescriptive. You know, the site doesn't only do these projects, but they're there to help inspire teachers and students about the kinds of things that are possible. I make them available as, they're also available online through GitHub as Creative Commons licensed. Awesome, thank you. They're Creative Commons licensed and they're available as Word documents. So teachers essentially treat them as a jumping off point. They're a starting point so teachers can create their own activities and lessons. So in the time I've got left, I want to show you a couple of examples to give you an idea of what sorts of worksheets I've got. So this one, for example, is based on smart assistants like the Alexa or Google Home or that kind of thing. So students pick a couple of devices that they want their sort of virtual assistant to be able to turn on. They create buckets for each device, and then they write some examples, some training examples for how they would give the command to turn on that device. Once they've collected a handful of examples, they use this to train a machine learning model. And then in Scratch, they can make a virtual assistant, something that they can give it a command, you know, phrased in natural language. It will understand what they mean and then animate the right sprite. And because there are blocks to do confidence scores as well as just recognizing the classification, it means they can sort of experiment with that as well. So, you know, they can add in a block that says if the confidence is less than 70%, then say I don't understand. So they can handle, you know, irrelevant out-of-band sort of data. I won't go through all the examples. Let's do this one. This was a fun one. It's sentiment analysis. So they create buckets for kind things and mean things, compliments and insults. They write the kindest compliments they can think of in one bucket, the meanest insults they can think of in another bucket, and they're looking to train a machine learning model to recognize the use of language in compliments as opposed to insults. And then they can make characters. I mean, normally they draw their own characters, but I'm rubbish at drawing, so I just use emojis. But they can make a character that can respond, change its expression based on whether or not you say something kind to it or say something mean to it. And often that degenerates into the classes trying to make the character cry. But there are loads of things that students can do. You know, the worksheets are there to start the students off, but because by putting the machine learning model in a platform like Scratch that they're already familiar with, it gives them a chance to be really creative and do all sorts of things. You know, with this project, we were looking at handwriting recognition. So they pick a few postal locations and they draw what in the UK I'd call a postcode. I think in the US, the equivalent would be like the 2-letter codes for your states. The abbreviations for state names. So we pick a few ones. They draw onto an on-screen canvas to collect some training examples of how they would write that. And then once they've collected enough examples, we train a machine learning model to recognize their handwriting. And then we make a postman game in Scratch that they can draw onto an envelope. And then when they click on the stamp, it recognizes what they've written and sends the envelope to the right sorting location. So there's loads of cool things like that they can do. So I will wrap up. So my goal, like I said, is to try and enable students to learn about ML through first-hand experiences, through hands-on experiences, through a simple training tool and integration with environments they're familiar with so they can use it as a sandbox to create an experiment with. And I think that's pretty much it.
1 minute and 30 seconds.
Perfect. Let's see if I can find the chat. Where has that gone? Were there any questions that I can't see?
The chat looks like there was a comment.
Okay.
I have a question if I could verbalize.
Yeah.
Is this a regular Scratch that you upload these extensions, or it's a special fork of Scratch? Would you be kind to explain?
It's the latter. It's a modified version of Scratch to support extensions. The public Scratch doesn't yet have, although the code isn't there for an extension framework, it's not publicly available. So I sort of jumped the gun and I'm using a fork.
Thank you.
Brilliant. Thank you very much for listening.
Thank you, Dale. Okay. We're going to move along to our last but not least presentation. This is Kayla Desportes, Yav Bergner, pardon me if I'm mispronouncing your name, and Willie Payne from New York University. And I believe Willie Payne is going to be leading this talk. So the floor is yours, Willie.
Kayla will start, actually.
Yeah. Hey guys. So we're also another kind of tool that helps you kind of take advantage of the teachable machine models, but specifically with the pose data. And so our tool is called Dance On, and it's part of a grant that we received from the NSF working across NYU, which is where we're from, University of Colorado Boulder, and with an organization called STEM from Dance. And basically we were trying to understand how we could help develop these expressive computing technologies and curricula for engaging women in physical movement, specifically dance, data science, machine learning, and physical computing. But the tool is really kind of targeted at dance, data science, and machine learning. And so we worked with this organization called STEM from Dance, who their kind of whole goal is how can we support young women of color in getting exposed to and engaged with different STEM disciplines. And so kind of the three tenets that we think that our tool fits in that we tried to design around is how can we help support expressivity in these culturally relevant ways? How can we help build expertise across dance, data science, and machine learning? And then lastly, how can learners leverage their knowledge about their body and dancing to support their learning about data science and machine learning? And so I'm going to turn it back over to Willie to give you the rundown on the tool.
Cool. So we're specifically going to talk about Dance On, which is an approach to teaching computer science targeted towards young women of color who are underrepresented in STEM fields. It's intended to be culturally responsive, enable creative coding practice, and use body and movement as metaphors to aid in data literacy and computational thinking. And the tool itself, I think, contains these sort of three main components. And it's so cool seeing these first two presentations because our work builds on a lot of that work. So you'll see a lot of familiar stuff. But it includes a web-based programming environment, a video panel with built-in pose detection, and a custom programming language that we've been iterating on called the domain-specific language. So this is a quick screenshot of Dance On. On the left side is the programming editor, and then on the right side is a video and webcam panel that has pose detection. Artificial intelligence and machine learning are incorporated in sort of two main ways. You have access to position data of different points on your body. This uses PoseNet and OpenPose. And then as the third presentation today, it also supports Teachable Machine for training models and then integrating them into your code. And I'll show an example of that. To date, we have developed a prototype of Dance On in really close contact with administrators and instructors from STEM from Dance. We deployed it in a STEM from Dance summer camp called Girls Rise Up that was made remote due to COVID. So about 20 young women have used the tool and worked on projects in 4 different teams. And we just submitted and got the work accepted to a conference called Computer Human Interaction, or CHI, where there's a bunch more detail. And I've also uploaded that paper into the Google Drive for this breakout room. And then currently we're hiring for an extended 12-week-long internship where a group of about 5 young women are going to work on projects with Dance On, learn the tools, and give us feedback about how to make it even better. We just posted the application a couple days ago and already have 6 applicants. All right, so now I'm going to scroll and show a demo. So this is Dance On. In our code on the left, our functions basically work having inputs and outputs, and the important input is pose. which captures, can people see this out of interest? Okay,
Yes,
good. I
we can
wasn't
see.
sure if I
We can
shared
see
my
too.
screen wrong. I can't see chat at the moment. So pose is a data source that includes our body data information, and then our output is a list of animations. And so in this case, I've got some code that I've hidden that just draws some circles to follow our dancer's wrists that I've called pom-pom. So you'll see these red circles. And what we're going to do together today is try to write some code that displays the text boosh at this awesome moment when she dances and raises her hands in the air. So at this moment, and right now I'm scrolling through the video. So one thing we might want to do to, actually I'll take a step back. So dance-on programs consist of these 4 different natural language identifiers: what, when, where, and how. So what is the type of animation that we want to draw? When, which is what we're going to write together, is when we actually draw that animation. Where is where on the screen, and then how is some information about it. So like the color or the size. So if we want to draw the words boosh when our hands are in the air, we might kind of try to identify a region of the screen. So what I'm going to do is in my controls, I'm going to toggle an overlay called cursor position. And this displays the pixel location of our video panel. So when our hands are in the air, it looks like the Y value is about 120. And so I'm going to write some code and change this word false to say when Y is less than 120 for our wrists, then we want to draw the text. So pose dot, oops, Y. And then now, at that specific moment, you'll see the word boosh. But a problem with this kind of absolute condition saying 120 is that if this code was ported into somebody else's uploaded dance video, or if I moved closer and further back from the camera, that absolute condition might not work so well anymore. So
5 minutes remaining.
Okay, thanks. Instead, we might want to write more of a relative condition. So I'm going to turn off my cursor position overlay and instead turn on this skeleton overlay. And this displays the points, the coordinates of our body that we have access to. So instead of saying Y is less than 120, we might compare the position of our wrists to the position of a point on our face. So in this case, how about our nose? So we'll say pose.nose.y. And so now the same thing, the condition's a little bit different. But in this case, when our wrists are above our nose, we display the text boosh. So a third type of thing that we might want to experiment with is not just us, the person, having to write these rules, but training machine to do it. And so in this tab, I'm using a model that Kayla trained with Teachable Machine. This is going to demo some of what Alex was talking about. And this model has 2 labels, one that's been trained with hands up and one that's been trained with hands down. And so I'm going to this time toggle a third overlay. That's our Teachable Machine classifier. And now you'll see in the top right corner of our video panel, it's going to display those 2 labels for each frame of the video. So right now, our hands are down. And this was an example that Alex gave, but we can see a couple frames where we're kind of right in between and it's not exactly sure what to predict. So when our hands are about at face level or eye level, it's split between hands up and hands down. But so if I wanted to write this code, TM stands for Teachable Machine. And we'll use our hands up. We'll say something like when the probability that our hands up is greater than 0.9, that's when we want to draw the text. And so once again, it's working and I could click play. And I went through that really fast, but I will stop right there for questions.
Two minutes and 20 seconds remaining.
Great. Okay, cool.
You want to share one of the video examples, Willie?
Oh, yes.
This will show you kind of what the animations can actually look like, which gets pretty cool.
This was a mistake because I deleted the video slides to post to the PDF in Drive, and I spaced it out. So this is what one team made. Oops. I'm probably not sharing my screen anymore.
Right.
Here we go. So this is one example of what a team made over the summer. Go to the next slide. Yeah.
1 minute remaining.
That first team's project was called Colorful Escape, and they basically started in kind of a grayscale, and then as their dance performance progressed, becomes more and more and more colorful and gets crazier and crazier. And then the second team was called Dripping with Power, and they animated this rainstorm that gets more and more and more intense, that matches the lyrics of the song, describing more and more intense emotions.
Yeah, and the kind of background code that's running is P5.js. So students are creating these animations using like circles, rectangles, lines, and that kind of stuff. And then you can bind it to your current pose data, but also past pose data, so you can get animations over time.
All right, thank you all. Appreciate your presentation, Kayla, Willie, and y'all. This concludes our track for this session. I'm going to post right now the main link to get you back to the main track, and you all can, head towards the main track.